Paulson, and I am a professor in the Department of Atmospheric and Oceanic Sciences and also the vice chair of that department here at UCLA. And I'm here to tell you about a study that we did mostly about 3 years ago, but I also have some very recent data looking at air quality around Santa Monica Airport. And first I'd like to say thank you for inviting me. I'm really sorry that I couldn't be there in person. And so thanks to the elected officials who put this together. I'm sorry that I'll miss my colleagues, and I'm sorry that I'll also miss seeing my neighbors who are there in the audience. And so before I start, I want to tell you a little bit about the people who did most of the work. Shishan Hu was a postdoc in our group, and Wanshik Choi is also a postdoc, done some of the more recent work. There are a number of people who are at the California Air Resources Board who have been integral to the study and to maintaining the vehicle that we use. And the work was supported by the California Air Resources Board. And I also want to mention that my co-principal investigator, Arthur Weiner, led this project together with myself. So when we go around and measure air quality in the vicinity of Santa Monica Airport and other places around Los Angeles, we use an electric vehicle that has a whole bunch of cool new instruments on it. And the electric vehicle is great because it has no emissions of its own, so there's no self-pollution issues. And I'm not going to go into in any detail the instruments that are on board, but they are state-of-the-art instruments, particularly in that they are very fast so that they can collect meaningful data as we drive around. And I am going to talk mostly about ultrafine particles and black carbon, which is kind of that sooty material, and a little bit about particle-bound polyaromatic hydrocarbons. And I think that my other colleagues have already talked to you about what those are, and if you have questions about them, then they can certainly answer them. The measurements that we made in 2008 were made mostly at the 4 dots that are on this map, and then we also used as a background site this site over here. We did drive all around Santa Monica Airport, and we found on the days that we were measuring very little signal from the airport anywhere except in this neighborhood that is downwind of the takeoff area under typical wind conditions. And I also want to note that the background site, you'll notice, is very close to the 10 freeway. During the daytime, that site is upwind of the 10 freeway, so even though it's pretty close, we don't see much of an effect. It is quite close to Ocean Park Boulevard, which has a similar amount of traffic as Bundy Boulevard. So from that point of view, it's kind of similar in its proximity to a major surface street as some of the sites at the end of Clarkson and some of the other sites around the Santa Monica Airport. So this just shows the wind direction, where the wind was coming from on most of our measurement days. I don't have the data for 2011, but this is typical daytime conditions in Santa Monica. The wind comes from the southwest, and if you notice the orientation of the airport in the last slide, you will have noticed that the airport is kind of perfectly lined up so that aircraft will be taking off into the wind under the prevailing winds. As we all know, on the west side we have this sea breeze coming in every day, and that was true on all of our sampling days. They were kind of typical sea breeze days. So this slide has some information that you have to think about a little bit. It's plotted in a little bit of an unusual way. So in this plot, we're showing ultrafine particle concentrations and time. There's a little over about an hour on this part of the curve, and another 40 minutes or so in this part in the afternoon, and this is around noon. And each of the lines here, each of the black dotted lines, shows a power of 10 increase in concentration. So the particle concentrations are going up a tremendous amount between each one of these lines. And also shown here is the residential average for the neighborhoods around Santa Monica Airport. And the blue line is actually the level of particles that we measure on Bundy Drive removed from the airport. So that shows you, if you were actually on the road, the concentrations that you would be experiencing there. And it's very clear immediately that the concentrations in the neighborhood, so these are all measurements that are taken at the site at the end of Clarkson Road, right in the cul-de-sac, in the neighborhood that's immediately downwind of the takeoff area from Santa Monica Airport. And we see that the particle concentrations are kind of near the residential average initially, and there's some a peak from maybe some earlier aircraft activity. And then we see a major elevation in particle levels that persist for the better part of an hour after that. And up here we have the aircraft activities. The A's are arrivals and the D's are departures. So we see planes coming and going, and we see the particle concentrations going up to very high levels, in this case up to several million, which is a concentration that we would typically only see if we were right in the plume following behind a diesel truck, for example, in an urban area. So we don't see those commonly except in these exceptional situations. And we see the particle concentrations remain very elevated, so over 100,000, whereas the residential average would be below 10,000 in that neighborhood for most of the hour. In the afternoon, the levels are generally quite a bit lower. That's expected because in the afternoons the wind speeds are higher, so the atmosphere mixes and the pollutants are diluted more rapidly away from the source, but still we see highly elevated concentrations at regular intervals throughout the period. The polyaromatic hydrocarbons and black carbon are plotted on a linear scale, and we see really large peaks associated particularly with departure events, but not so much the arrivals. So we see big spikes in these concentrations, and the background for these things is very low, so those are also quite elevated. This shows the average concentrations of ultrafine particles and black carbon at the 4 different sites that we made measurements at where we had stopped our mobile platform. Clarkson Avenue, Bundy and National, that's at the gas station right at that intersection. Brookhaven and Barrington, which is a site that's directly downwind but almost 700 meters downwind. And relative to the background concentration for ultrafine particles and black carbon, and in both cases we see that for all of our measurements taken together when we were there, the levels are elevated relative to the background. And for someone like myself who spent a lot of time studying the influence of freeways and the size of freeway plumes, these results are pretty surprising because during the day when these measurements were made, we would not expect to be able to see any signature of the freeway more than about 300 meters downwind. And from the airport, we're seeing, under relatively windy daytime conditions, elevated concentrations even nearly 700 meters downwind. So this speaks to the observation that individual aircraft have extremely high levels of ultrafine particles and related pollutants, and that they're not diluted particularly effectively. They're not followed by another vehicle, which tends to mix the pollutants away and so on. So there's a relatively and kind of surprisingly high impact area. So this data shows, this is data that I haven't shown before in public. It's data that looks at concentrations of ultrafine particles in different neighborhoods in the area. So this little area is what we're calling Santa Monica Airport. It's 1 street away from the little cul-de-sacs that go up to the takeoff area. And other areas, all of them are removed so that we don't expect to see any direct effect of the freeways. And they don't include the major surface streets, which have a little bit higher concentrations, but typically lower than what we would see from the aircraft activity. And so we have levels for each of these 4 microenvironments. And when we look at the levels, we have data here for 2008. This is several days averaged together, 4 or 5 days. These are single-day results for 2011. They're measurements that we were making before and after and during Carmageddon, because we're interested in what that did to the pollutant concentrations. And in this plot, we have what we call interquartile distances. So the bottom of the bar represents the lowest 25% of the measurements, and the top of the bar is the 75th percentile, and the middle is the median. And then this goes 90 or 10% to 90th percentile, 5% to 95th percentile. So we can see the full range of the data in each of these microenvironments. So the other neighborhoods are pretty similar. It's a little bit higher. This one is downwind of the 405 and the 10 freeways. But generally same area. Santa Monica Airport neighborhood clearly stands out as highly elevated compared to these other neighborhoods. And these are just single days, and they're over a relatively short time period. We haven't looked at what the aircraft activity was during those time periods, and that's probably that combined with meteorological variability is what's responsible for the variations from day to day. But during Carmageddon, we see that the air was really clean. Hardly anybody was driving. It was really quite a remarkable day. And indeed, we saw that in the particle concentrations, very, very, very low levels of these pollutants, except in the neighborhood that's downwind of Santa Monica Airport. And this just shows, I don't have time to go into the detail, but basically what's plotted on this axis is a proxy for the size of the aircraft or the fuel consumption rate. And this shows peak ultrafine particle concentrations. And associated with activities of aircraft, we got the data for which particular aircraft was taking off at each particular time. And it shows basically exactly what you would expect. Larger aircraft produce more particles. There's one other point that's not on here. It's somewhere over in the neighborhood over here. And that's a very large jet that produced really, really large concentrations. So the smaller aircraft are producing much less, and the jets are contributing a lot more. So in summary, the concentrations of freshly emitted pollutants are consistently elevated in the neighborhoods downwind of Santa Monica Airport. And I'd like to thank you very much for your attention. And if you have questions, then you should ask my colleague Phil Fine, and I think he'll do an excellent job of answering whatever you might have about our part of the presentation. Thank you.